All right, good morning or afternoon, Conditional Probabilities group. So over the last couple of weeks, I have noticed that we have been struggling a little bit with some of us with the two-way tables and especially with our probability distribution tables. So we're going to take a look at that today. Make sure that you have this set of notes so you can follow along and work on these problems and write down all these problems and along with you or while you're watching this video because you will be able to use these notes as you are working on your IXLs and also as you complete your exit ticket today. So first off, from Algebra 1 KK.4, this IXL was specifically looking at our two-way tables and identifying conditional probabilities from there. If you need a reminder of what conditional probabilities are, we did take notes about these on our Focus Friday a few weeks ago. So go back and look at that first set of notes that we took. But in terms of like how we kind of basically go through this two-way table format, you're going to start by identifying the given or identifying that condition. This is what we know. We know that the given has already occurred. And this, so when we're thinking about the probability, this is going to be the total that you're pulling from, the total possible outcomes. Then we're going to identify that question. What within that given are we interested in? Set up our fraction and answer by either simplifying the fraction, finding the decimal if we're working in decimal form, or finding the probability, the percent if we're working in percent form. So let's take a look at this example from IXL. Lillian was the lucky journalist assigned to cover the best beard competition. She recorded the contestants' beard colors in her notepad. Lillian also noted if the contestants were signed up for the mustache competition later in the day. So looking at our table here, I see over on the left, I have the three different colors of beard. And on the top, I've got if those members of the competition were only in the beard competition or if they were also in the mustache competition. Below, I'm seeing the question, what is the probability that a randomly selected contestant has a black beard given, I'm going to underline that word, given that the contestant is also in the mustache competition. Morning. So here we see that we are given that they're in the mustache competition. So we know that the mustache competition here is true. This is where our total is going to come from. What that also means is if it's helpful for you, you can cross off all of the people only in the beard competition. So if we add all these up, we see that there are 13 people in the mustache competition as well. And of those 13 people, how many of them have the black beard? Well, 6 of them. So we're going to do 6 over 13. It tells us to simplify any fractions, but we can't actually simplify this. So we would have 6 over 13 as our answer. Let's look at a second example as well. To get to know her students better, Ms. Wilkerson surveyed her math students to determine what hobbies and school subjects they prefer. So I see here that we've got the hobbies on the left, we've got athletics, we've got the arts, we've got reading, and we've got other hobbies. And then on the top, we have math and literature. So this is asking us then, what is the probability that a randomly selected student prefers athletics given that the student prefers math? So this is our condition. This is going to be where our total comes from. So we know for a fact that the student that Ms. Wilkerson selects prefers math. So we can cross off all the people that prefer literature. We can add those people up. So we have 8, 9, 8, and 11 would give us a total of 36 students who prefer math. And of those students who prefer math, 8 of them prefer athletics. So we can use that 8 on top here. and then we can reduce this fraction. So I showed a lot of us how to reduce fractions in the calculator, but just to remind us as well how to reduce fractions here, I'm looking for a common value or a common factor in both the numerator and the denominator. I'm looking here and I'm seeing, oh, I can divide 8 by 4, and I can divide 36 by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. So that would simplify to 2/9. So that's kind of the basics of using these two-way tables. That, again, was from your Algebra 1 IXL KK.4. So if you haven't finished that one, these would be a couple examples you could use as you are working through the rest of Algebra 1 KK.4. After this, we moved into our Algebra 2 00.8. This is when we started looking at the probability distributions. We learned about the formula. Most of us have done really well with the formula part of 00.8, but when we get to these probability distribution tables, that's where we kind of have been getting stuck. So remember that a probability distribution shows all possible outcomes and their probabilities for a particular sample space. Conditional probability symbolically is written like we have here, where we have the probability of A given B. So when we're looking here, this line says given, so B is our condition. Whatever comes after the line is the condition. So we're going to identify the condition. And again, the total from our condition is going to be the total that we use as we're doing our probability. And then we're going to identify any outcomes that count for A that are left over after we cross off everything that's not in the condition. And we can add those probabilities together if there's more than one, and then do our basic calculation for our probability. Let's look at a couple examples here. The table gives a set of outcomes and their probabilities. Let A be the event, the outcome is a divisor of 6, and B be the event, the outcome is prime. Find the probability of A given B. So B is our condition. What that means here is that the outcome is prime must be true. So we can cross off any of these values over on the left, any of these outcomes that are not prime. So 6 is not prime, 4 is not prime, and don't forget this one, 1 is not prime. So my total for the probability of B by itself for my condition is going to be that 0.28 plus 0.17 plus 0.05. It's what's left over. So if we do that addition, we have 0.5. So the probability of just the outcome being prime is 0.5. Now from what's left, we're going to look at event A, which is a divisor of 6. So looking at what's left, we're thinking, what is a divisor of 6? This is essentially us looking for the probability of A and B, right? Because we've already crossed off everything that's not B. So everything that's left here that counts for A is the probability, goes into the probability of A and B. So I know that 2 is a divisor of 6, 3 is a divisor of 6, but 5 is not a divisor of 6. Remember, we can also think of divisor as factor. So I'm going to add up my 0.28 plus my 0.17, which gives me 0.45. And then I need to do my division. 0.45 divided by 0.5, which would give us 0.9. And here we can actually put that decimal in, 9/10. Let's look at one other example and then have you jump back into 00.8 if you don't have that finished yet. And absolutely using this, when we get to our exit ticket for today. So hopping over to our last example, the table gives a set of outcomes and their probabilities. A is the event, the outcome is divisible by 2. B is the event, the outcome is less than or equal to 9. Find the probability of A given B. So again, this B is our condition. So we can cross off anything that is not less than or equal to 9. In this case, it's only 10. So we could either here, since we only crossed off one thing, we can either add all of these things together, or we can say, well, I know that this whole probability table or probability distribution has to add up to 1. So the probability of just B is going to be 1 minus this one that we crossed off, 0.4. It's just a little bit easier, but you should get the same thing if you just added all of these together. It would still give you 0.6, whichever way works best for you. Now we need to find our probability of A and B. We've already crossed off 10, so we can't use 10 anymore. We're now looking for anything that is divisible by 2. So I've got 2, 4, 6, and 8. So A and B, we need to add up these 4 probabilities. So 0.023 plus 0.098 plus 0.013 plus 0.016. So adding all those up. Would give us 0.15. And then we can do our division. My probability of A and B divided by just my probability of B gives us 0.25, and we can add, and that would be our answer over here. Hopefully this is helpful for everyone, and let me know if you have any additional questions.